Hey, what's up, everyone? I'll let people kind of trickle in for a second here. Another just absolutely fantastic day to write some code. So I'm pumped. If you want to get started, we're going to be cleaning some data here. If you want to get a little bit of a head start, you can check out this GitHub repo. Where are people watching from? Very curious. Where are people tuning in from? I need to know. Got Turkey. Nice. It's probably pretty late. Probably fairly late. Florida, nice. Wyoming, Italy. Italy's beautiful. Ukraine, all over the place. I love it. Awesome. Again, if you want to kind of follow along, you can check out the Olympics data set that I have hovering on the screen. Got some India, Pakistan, all the fun places. Morocco. A lot of places I would love to visit for sure. All right. The link is also in the description. I'm going to get started. I feel like we could probably spend a good amount of time doing this, so might as well get going. Unclear yet if I'll do some analysis as well. Definitely we'll do all the cleaning. We can start doing the analysis. End-to-end model implementation with deployment. Definitely at some point we'll do something more production grade. It's definitely it's one thing to build the production grade model. It's another thing to make the video on production grade models. So I feel like that's one thing that I struggle with sometimes is like the harder things to build are also harder to build tutorials on. Cool. So in this video, I'm prepping another like comprehensive Python Pandas tutorial, and I figured a great data set to do for that would be an Olympics athletics data set. The one that I posted, 4 years or so now, maybe 5 years ago, was on Pokemon data, which I feel like was a fun data set. I'm trying to find another fun data set to kind of like capture all the new things you can do in pandas. And I feel like the Olympics data set is a pretty good one to do. Again, link is here, also in the description. And so what we're going to be doing is we'll first just kind of discuss how this data set was even collected. I feel like that's a good starting point because I want to kind of showcase the process. And then we'll actually clean the data set with Python Pandas. Hopefully you all can follow along. It should be fairly straightforward, and I hope to make it interactive so that you can provide me with a bunch of suggestions and criticize all of the work that I do as we go. And then I'll answer questions throughout, but I also try to reserve some time at the end to kind of do a Q&A. So let's get started with and about the data set. So let me showcase the GitHub page. I'm still working, learning how to figure out all this live stream stuff, but hopefully you all can see this. So this is the GitHub link. It contains in this athletes and results folders, there's two CSV files that contain a bunch of data. So probably a good starting point would be this athletes data. We can look at bios. I guess we can't see, but if I click on raw, we should be able to see something here. I guess this is really hard to see. What I'll do instead is show you how this is collected, and then we'll kind of actually start looking at it with Python Pandas. It'll probably be easier. But athletes bios.csv is one of the data files, and then the other data file is results.csv. And basically, if you go down in the description, we can see that the data comes from olympedia.org and it was scraped using Python beautifulsoup. So actually, I'm going to also hide this overlay, I guess, at this point. People hopefully have the link. basically, there's the site olympedia.org. I'll click on that real quick. And on this website, shout out to olympedia.org, but they have like all the stats, analytics on all the athletes that have ever competed, at least since, I guess it doesn't have the ancient Greek games, but since 1896, it has like information on and bio info on all the athletes that have competed. So I thought this was a really cool data set, but in its website form, it's not the most like easy to do the types of analysis that we might want to do on our own with Python. But what I found was that if you go to athletes, and so for example, we could even click on like Michael Phelps here. But what I noticed with this website is they basically always follow the same format. You have this biographical information over here. And, that is one thing that we might want to scrape out. And then down below, we have all of the results, and Michael Phelps definitely has a seriously good record of results. But you can see that there's a table of all of Michael Phelps' results from all the Olympic Games he competed in. So the basic idea behind this data set is, hey, let's scrape this, and let's scrape all of this for each athlete in the database. So then the next question is, okay, how do we get each athlete in the database? And I don't know if you can see this. It's really small on my screen. I don't know how to just make the bar here bigger. So I can just kind of put it as a caption overlaid on the screen. But the URL I'm on is athletes 93,860. And what I noticed about this URL here down on the bottom left, it's showing, is that we could plug in random numbers here. So let's do like 4,000. We see that we get someone named Christy McLaughlin. If we change this URL, now I'm going to change it to like 2,300. We get Yao Yan. And same type of thing. There's this biographical information, and then this individual's results in the Olympics. So the basic idea with scraping all of this data kind of comes in that if we just incremented this number, so 3, 4, 5, 6, and programmatically did this, we could get to all the pages with all the athlete information, and then ultimately scrape it and put it into a data set. So when we look at the GitHub repo, if I go back to the GitHub repo, somewhere around here, basically that's the process that was followed, that in the athletes and the bios, that was all of those bio information that you saw. This was kind of scraped through, just went 1 to 200,000 and pulled all that information. And then same thing, pulled the results 1 to 200,000. There's a file called scrape data if you're curious to see how that was done. One thing that I thought was helpful, there's like PD read HTML file, pandas read HTML. It was super helpful in this. And then another thing I did is I saved temporary CSVs as this kind of went. So I just ran this on an EC2 instance in the cloud and just let it run over I think it took a couple days. I didn't optimize the code here, but I made sure to checkpoint the CSV as it went. But that's a little bit about the data. We'll start exploring it, but I did want to give that context on what we're ultimately cleaning. The outputs are in bios.csv and results.csv, so hopefully that is helpful. Going back to the presentation, I think now we can start actually getting into cleaning the data set. All right, so how can we go ahead and do that? Well, I recommend, sorry, I'm figuring out my screen. What I'm going to do is I'm going to go ahead and clone this repo. If you don't know how to do this exactly, I'll show you another way that's easier to maybe just follow along with the actual CSV files. But I would go to code, copy this to my clipboard and then open up a terminal window. I'll go into my YouTube. I think I have a YouTube folder. Let's see. Yeah. And then I'm going to go into my code folder. And then I'm going to go ahead and make this a little bigger. Make it bigger. No. And then I'll go ahead and do a git clone, and I'll paste in that link that you saw. Now I have this in the code folder, so we can see Olympics dataset. I can go into that, and you could definitely open like a Jupyter notebook here, but I've been just using Visual Studio Code for most of my work these days. So I'm going to go ahead and open up Visual Studio Code. I think I already have it open. You just can't see. Probably it's very small. I'll try to make everything as big as possible. If you can't see anything at ever, just let me know in the chat, and I'll try to do my best to make things bigger. But I'm going to open up that thing we just opened. So it's in my home, and it was in YouTube. I have a YouTube folder somewhere here. YouTube, code, Olympics dataset. I'm going to open that. Cool. All right. And then I probably want to make some sort of Jupyter notebook. So I'm going to call this clean data.ipython notebook. I see a question in the chat. I'll show it on the screen because I think this is kind of cool. What kind of data set are we using? It's a CSV file, and I'll show that in 1 second and how big. It's like under 50 megabytes. It should be very manageable for everyone to work alongside. So I recommend opening up a Jupyter notebook if you want to follow along. Again, the repo is in the description of the video. And thank you, Daydreamer, for the kind comment. I'll try to do more live streams. I think this is kind of fun. It's definitely something I'm slowly getting more comfortable with. So I think it's just a matter of finding topics and then also just making it more consistent, trying to have a schedule. But all right, we're in our repo. We have this clean data.ipython notebook file. And kind of with anything pandas, probably the first step we want to do is import pandas as PD. Pick Python environment. I think Python 3.11.7 is what I use mostly. Okay. And now we want to actually load in our data. So where is our data? Well, it's in athletes. We'll start with the bios.csv. So I'll call this bios equals pd.read CSV. Yeah, VS Code will be able to run any Python version that you have. By default, you might have to install the Python version that you need, but you'll be able to link it with VS Code. They kind of operate separately. All right, read CSV, and then we want to go into athletes, and it was in bios.csv. And probably people that are maybe just tuning in will be like, oh, where's this athletes folder? How do I access this? I'll show a trick in 1 sec, but we load that, and I can go ahead and do bios.head. And hard to read because this is so big, but we do see we have some athlete information here. We have gender, we have their name, born, died, the Olympic committee that they participated with. I added this athlete ID, which is the URL ID of where that scraped information came from. All of that looks good. So this is what we're going to be working off of. And right now it's kind of a lot to look at. So hopefully by the end of the video, we make it not kind of a lot to look at. So that's the goal of the video. But another trick real quick, if you don't have this code locally that I just find is so useful and I wish more people knew about, and hopefully, after this video, more people will know about. But one cool trick you can do is if you're on the GitHub repo, that link is really small. I apologize, but again, it is right here. If you're on the GitHub repo and you go into athletes and then you click on bios.csv. You can click on the raw file here, and you see this massive wall of text, which is all of the data in that CSV file. You can actually copy this URL here, and this is specifically for the raw file. So make sure that you're using the raw file if you're going to follow this way. But I copied that URL, and now I'm going to go back, and I'm going to just paste in the URL. So this is just the URL for where this lives in GitHub. I can rerun this and it's going to take a sec because it has to now download all of that, but 2.6 seconds, that's not bad. And then I can also get the data that way. So hopefully that's a cool little trick. If people didn't know that you could do that, you can actually paste in URLs if they're the proper format, which oftentimes on GitHub, if you go to the raw file specifically, so again, it's this URL right here, it is the correct format. I see a comment here. I'm not sure if you have time, but it would be amazing to watch how you code the script of the scraping code to learn how you structure it. I was thinking about making this full thing a live stream, but the issue with the scraping code, and maybe this I'm like overthinking it, but it took multiple days to run. So it's like to get the full data set, and I probably could have optimized the data. It probably could have taken quicker than this, but to get the whole data set, it took a while. So I like kind of skipped that step. But I think there will be more web scraping stuff in the near future. So hopefully we can do something like that. And I do have other web scraping stuff on my channel, shameless self-promotion. You can, look up web scraping in my name, probably find something. Cool. All right. So I think that this is a good starting point. Hopefully everyone has like the data if you're following along. But I think what I see if I look at a data set like this is the first step with any sort of cleaning. I mean, I'm asking myself a few questions. I'm asking myself, um, what is my ultimate goal from this data set? What the heck? Sorry, watches. I'm going to turn on do not disturb. What is my goal in the analysis on this data set? That should guide how I clean it, because sometimes you might need to keep certain pieces of information and can get rid of other pieces of information, and that's all dependent on what your goal is. So like an example is that we'll probably see as we start cleaning this is like dates. Like, is it important to have the day and the month in the date? Or is it just important to have the year? This will kind of change how we clean things. We need to ask ourselves what's important, what's not, and that's going to guide how we clean things. Uh, I see a comment here. Oh no, that was not the comment I want to show. If I ever run into you in Boston, free coffee on me, I will 100% take you up on that offer. So I am crossing my fingers that we run into each other. I drink way too much coffee. What was I going to say? So like we need to ask ourselves questions on what we need to do to guide how we clean the data. So I think this is a good like point to just ask all of you, like what seeing this data set, and ultimately my goal with this data set is to be able to analyze all sorts of interesting things about these athletes. Look at their height, look at their weight, look at the years they competed, how many competed when. What types of things do you think we want to do to clean up this data set? So I'm going to write down here, like, make this a markdown cell by doing escape and then M. Escape M. What should we clean up? So let's just gather a list here. Anyone have ideas on what we should clean up? I will start putting them in myself, but I want to hear other people's ideas because I definitely probably will miss some on my own. So looking at this data set, looking at these columns, et cetera, what are some things we might want to clean up? There might be a lag too on when I see the chat, so I don't know how much that lag is. Make this a markdown cell too. One cool thing is, all right, null values. outliers. I guess I mean, yeah, we definitely probably want to do stuff with null values and outliers. Um, but I think I like to ask myself more specific, um, I guess, guided questions with our data. Like, is there specific things that I know I might want to do here? The goal is to like analyze all sorts of things. So I specifically want to like analyze dates people were born, their heights, their weights, what was average, what's not average, maybe look at countries, etc. Outliers is good. Outliers would more be part of the probably analysis step that I might get rid of. Shout out Ayush. I see you in the comments. Thank you for the kind words, and thank you. Ayush helps me with a lot of editing type stuff. So shout out to him. All right. Okay. I'm gonna let me write down. I think I'm not being clear enough. So let me like write down a couple things of what I see. So like one thing that I immediately see is in this used name column, there's these like weird bullet points. So like one thing I immediately want to get rid of is like get rid of bullet points in used names. Yeah, data types is definitely something I want to play around with. Another thing I probably want to do as we clean this is that we just have like a lot of extra columns, and this goes along with like the null values. We see a ton of NaNs here. So I probably just want to like, this might be kind of a last step type thing, but I can't type. Get rid of extra columns. Like I only need to keep the columns that are really important to me for some sort of analysis. Yep, I see that. Remove unnecessary columns. Perfect. How about those with no correlation? Yeah, I mean, I think that we're talking about maybe the same thing. Like if there's things that just don't really relate to the data, we don't really need to keep them if we're just trying to analyze these athletes. Let me see if there's anything else that I'm missing here. Yeah, features that are not relevant, remove them. Anything else that people think we could clean up? And I guess like clean up maybe as a broad term. Ultimately, I want to make this data set more useful for analysis. So I incorporate any steps that make this data set more useful for analysis as cleaning the cleaning process. So I'll give one more second for people to provide ideas in the chat, but I probably will provide some more of my own. Give me as specific as possible in the chat. I love this one that just popped up on the screen. Split height and weight. Shout out Stefan. Yeah, if we see the measurements here, it's kind of hard to analyze this in its current format. I want to have it split on the height side, which is the centimeters, and the weight side, which is the kilograms. So definitely something that we will be doing. Yeah, and I see another one. Good comment. I think two people kind of said this, so shout out to both of them. Birthday date versus place. Yeah, like I want to separate this date from the location that they were born in. 100%, that's something that will make my life easier. When I'm analyzing this, one thing that I think is particularly cool is like I want to know what city most of these Olympic athletes came from, and like, is there something about that city that like is making it such a high probability that you have these Olympic athletes? So I definitely want to split that. Good idea. Also, see someone that had something similar here, so I want to give credit where credit is due. Definitely can standardize it. I see something that is pet names, which is the nicknames down here. Yeah, it's largely going to be useless for analysis. I think the only reason you'd keep this is it's fun. So to be determined if I would drop this. I would say probably, yeah, if my focus is analyzing like Olympics data information, yeah, I don't need to keep pet names, but it might be fun for just like seeing all the craziest pet names. But I might, I could do that separately than actually my more meaningful analysis. remove the symbols in use name. 100%. Yeah, the dots are going to get removed. I did put that down. So let me start writing some of this stuff, and then let's actually start working on this. So we have split height / weight. We have, I would say, parse out dates from, I'm going to say both the born column and the died column. I think those are both useful. We could see like who's the oldest Olympic athlete ever if we do that. Born, and one, I guess, nice thing I can do is born and died column. Let's see. I'm going to say parse out city, region, and country from born column. You could also do this for the died column, but it might be a lot to have both these locations. I think it's more interesting where they were born. Yeah, exactly. Expand. I like that idea. Yeah, calculating age at time of death. That would be an interesting thing to put as well. Oh, shoot. Sorry. There we go. Yeah, I definitely think that I agree with that. That could also be kind of done during our analysis step probably, but it's easy enough in the cleaning step. So I do like removing unnecessary columns, but athlete ID, it's kind of a column that I added specifically, and it's useful because in our other CSV file that we have, athlete ID can be used to join different athletes. So I think I'll keep this column, but I think that this is a good list to start. I do see I have a question, not related, but is it legal to have features like ethnic or races in crime analysis? I think that's a case-by-case scenario. I don't want to answer blankly. You always definitely need to be careful whenever ethnicity and race is involved. But yeah, just I would say case-by-case, just try to be careful and ask for people as you do that. Ask for help from people. Yeah, there's another good comment here. It is interesting that the location of the birth is not necessarily their National Olympic Committee. I believe that's what it stands for, National Olympic Committee, or wherever they competed for it. Yeah, we'll see in some of these examples that where they were born is not necessarily where they compete. Cool. This is a good list. One thing that I just do want to show is like the reason I put this list the way I did with the Markdown is because you can do a little checklist in Markdown like this. So like you see now it's a checked mark, a little small detail, but that's why it's a weird format here if you're curious. Cool. Let's go ahead and start doing this. We have our data in bios right now. One thing that I sometimes like to do is like I like to keep the original data as is, and I might just do the actual cleaning in a separate data frame. And I'm going to do escape Y to make this a code cell. So I might do df equals bios.copy, and just basically bios will always be our original. And then when we're pretty happy with our new data frame, we can clean it up. Yeah, we'll probably want to look at some data type stuff too. So I might also do like df.info real quick, see what types of data we have. This is probably more important as we start cleaning. Like we'll definitely want to make sure that like the born, when we split that into a date, has an actual date time field. And then we'll want to make sure that like height and weight are number. I can't even speak. We'll want to make sure height and weight are numerical columns. Cool. Anyone that has joined recently, the data that we are working off of can be found in the GitHub repo that's in the description. And also you can do something like this to just pull the data in locally as you see fit. All right, so let's start with an easy one. Let's get rid of bullet points and use names. So we have our data frame. We see that the used name has this weird bullet point in it. I do see in a comment that athlete's ID could be the index. I just worry because sometimes we'll do things that will switch up the index. So I'm just going to keep it away from the index for right now. df describe include equals O to check the data. I'm kind of curious what this does. Is that an O or a 0? Oh, I don't know what the include O does, but describe is always nice. Okay, but I'm going to go back to the head. All right. So, there are things you might want to do like NANs and like clean things broadly, but I feel like I kind of focus sometimes at a column at a time. Something like the bullet point here is very easy to handle. So what I might do to start, if I'm trying to just make that a space instead of having a bullet point there, I might just look at the length of my data frame. All right, we got 145,500 rows. And then I might do something like df, the use name is the one that has it, .string .contains, and we want that weird little bullet point. So I'm going to copy that. I'm curious how many rows actually have this. This is kind of like a little sanity type check thing. And I'll do this. And I might do the length of this. Is this the same amount as our... Yeah, it's the same exact length. So that basically proves that every single row has this bullet point. So we don't have to worry too much about null values or anything there. There's other ways that we could have done this, but you really pick the method that is easiest for you. So we're going ahead and we're going to get rid of those bullet points. So I might just make this a new column, name equals df use name. Oh, thank you for the comment on the shirt. How to make sure to wear a Hawaiian shirt today. Real bamboo buttons, high quality. Used name, and then we can do string, and we can do replace, and we want to replace the bullet point with a space. That should do the trick for us. Run that, df.head, and now what we see is that we look all the way over here. We got the name nicely with no bullet points. So that was one of the first tasks to do. All right, so I can go ahead and check this off. We'll probably get rid of use name at the end. So we'll move this to the bottom of the checklist. Oh no. Cool, that was easy enough. All right. All right, so name is over here. All right, what else can we do? The next thing on the list is splitting height and weight. Curious if anyone has any idea on how we could split this. Where did it go? Height and weight column, so measurements, into a separate height and a separate weight category. Anyone have any lines of Pandas code that we could use to add, I would say, a height column and a weight column to our data frame? There's two ways that immediately come to mind for how to do this, and I'll probably show both, but I feel like I learned so much when people add their own ways of doing things. There's always new things that I learn each day with Pandas type work. Hey, Matthew. Split by slash. I think that's definitely a great first step. So ways that we could do this. So ultimately our goal right now is we want to split the measurements column into height and weight columns. So we want to split by slash. If we wanted to do that, then it would look something like I think we can do df height, weight, and I believe we can do df measurements dot string dot split dot slash. If I run this looks like it should be good. We're gonna get an error. The reason we get an error, basically whenever you want to split into two new columns, there's this helpful keyword that allows us to do this nice and succinctly, which is expand equals true. What do I use? I mean, I'm using a Jupyter notebook, but I'm using it within Visual Studio Code. All right, so now I run that. Now, if we look at our data frame, cool. We look over here, we have height and we have a weight. So that's pretty good. That's thank you for the people that suggested the split by slash. However, I'm curious, do people have any ideas of things that, I mean, next steps here or things that we should maybe be considerate of before we just do this for every single column? So we're split by slash, but now I'm curious if either there's something we're missing here or if, like, what is the next step to make this actually useful, or more useful? Because if we look at df.info right now, we see height and weight are non-null objects, and I would probably prefer them to be some sort of numeric object. Yeah, I do really like this idea. That's a good first thing to do. So we could do height cm, weight cm, or weight kg. And then basically we can get rid of the cm and the kg from our measurements. I might just real quick also do a df.drop height. Can I do this? Columns equal height and weight. The ones we just added, I want to drop them. I think I need to do in place. Do I need to do in place equals true here? Just want to get rid of those. I don't want to have too many extra height and weight columns. Okay, height cm, weight cm, look at head. Yeah, we want to get rid of the cm and kg keywords. That is definitely one thing we want to do. So how might we do that? How might we get rid of height cm and weight kg? I think the other thing, I want to show this, hide. The other thing that I worry about is I worry about measurements that don't necessarily match this pattern. What if it doesn't have a slash in it? What happens? That's always something that I'm being cognizant of because I don't want to just like get rid of data that I shouldn't be. So there's two things we want to do right now. We want to check to make sure all values have the slash in it. And we also want to get rid of the CM and the KG from our data, our new columns. Okay, so let's do this first step to check. Yeah, you probably want to get rid of white space and stuff too. If you capitalize int, it will course the nulls. Yeah, that looks good. I see some suggestions already. I don't know. I don't like the idea of assigning the mean of height or weight column to those null values. Like, I guess if you wanted to do some average, maybe that's okay. But we have enough data here that we don't need to go ahead and assign means. Like, that's basically giving people values that they don't actually have. So I don't think it's fair that from someone in the early 1900s that maybe we don't know their height, maybe we don't know their weight. I don't think we want to just populate an average for them. There's so many other factors like what sport they're playing, uh, gender, uh, so many factors. I don't like assigning mean. I would just keep them as NANs, and basically our analysis will be on the values that we do have. All right. So first, let's make sure that the values all have the slash. So I think there's a couple things we can do here. So I'm going to just do a df measurements. And I'm going to do .string .contains a slash. That's going to be all the ones that follow the format that we're expecting, like that. So we can actually add this little squiggly line. Is that an ampersand? I don't actually know my character terminology, but oh, that doesn't like that. Why does it not like that? Oh, I guess there's a keyword here for NANs that it doesn't. You can do any equals false. So that basically just means any, not a number value returns false in this contains code. All right. So measurements, oh, it just gives us all the NANs. But actually what we're seeing down here is some people just have centimeters. And I bet you there are people that just have, oh, it's a tilde. Is there another word for tilde? Oh, ampersand, is that an and sign? I'm silly. So we see that, yeah, there's issues here. Another thing that make this even easier probably is we could make this a 2 condition thing. I could do and df measurements dot not na. All right. So yeah, now we see some different types of values here. So in addition to the slash, slash, we also need to be able to handle these types of cases where it's just the centimeters, it's just height, or it's just weight. I do see a comment here. The video is recorded. It'll stay up on my YouTube channel, so don't worry about missing the start. But yeah, we want to handle all of these cases. I think you have to be kind of considerate on your own whether or not, like how careful you need to be in your cleaning process. Like there might be other edge cases I'm missing right now, but I think as long as I handle the normal case, the ones that just have centimeters and just have kilograms, I'm pretty happy. If I really was being particular, I don't want to make this video take too long. But if I was being really particular, I might actually count up and make sure everything is adding to what I expect it to make sure that those are only types of cases. I might have like unit tests or something. But like as long as I handle most of the cases, I'm usually pretty happy in most scenarios, as long as it's not like mission critical data that if I have any mistakes, it will really cause harm. But okay, so we saw some different formats now. Now one thing that we can do, this is another little like trick, is I want to know what happens if I do a string.split on one of those cases like 180 centimeters. Like what happens in that scenario? So one thing that might be helpful to do is just like doing a little like I'm trying to think of a word here, like small data or something like that equals I like to sometimes make little toy examples for myself to see how things work. And this is recorded. I see someone asking again. It will be recorded. It will stay up. Don't worry about missing anything. So I have small data. This equals, we'll just say 183 centimeters. We'll have 180 centimeters / 150 kg. I work in the imperial system, so I sometimes don't remember. I think I'm like 190 centimeters. I'm trying to think what I would be in kg. I'm just like thinking of like the gym. Like how many 45-pound weights am I? I think that's like 20 kilograms. I don't know. 80 kg. Columns equals measurements. So I'm making a little toy example just to see what happens with that toy example, and that will help me actually apply it on our big example. Yeah, definitely. You'll be able to download my Jupyter notebook. I'll push it to the GitHub repo as we go. Okay, so here we have this little toy example. We have our measurements, and this is just helping me grasp if it's handling the edge cases right. Small data, and we'll copy what we have here. And that's going to equal small data, measurements, string spit, and then we'll look at the head of this. Okay. So it's still looking pretty good. We see that the height centimeters got to the right spot. We want to be careful with all of our edge cases though. So we might also pass in like 100 kg here and see what happens to that example. All right, and here's our first issue. If we string split and we have an example like 100 kg, then we're going to run into an issue because it's putting that now in the kg column, not the centimeter column that it should be. So things that we need to consider. I'm trying to be comprehensive. I'm trying to like track down these edge cases because we do want as much height information and weight information as we can get when we're cleaning our data set. We don't want to lose information if we don't need to. So this is just something that we'll have to handle. But it's just kind of cool to see with like little things like this, what might be able to help us in doing this. So I'm going to go back to our actual data frame. Okay. Right. So we'll start doing this, but we'll just have to be cognizant that we'll have to do something to handle this case right here. All right. So one thing we can do here to extract the centimeters and kilograms, one easy thing we could do is we could do df height centimeters equals df height centimeters. We can do a .string .extract. This lets you use regex patterns. So if I do regex, and this will become super useful, I think, in some of our other cleaning steps. I can do the regex pattern, and another shameless self-promotion. If you're watching this like after the fact, or if you have some time, if you're not familiar with regular expressions and you want to learn, I do have a pretty comprehensive video on regular expressions somewhere in my channel videos. So you can look up regular expression and my name, probably find it. But this is extracting just the digits from the height centimeters column. So if we look at this, we can do height, df.head. And I might, we're going to have to repeat some of these steps. We see we get the numbers there. However, we got to be careful because as we saw before, we might have kilogram values accidentally in here in the height centimeters column. So this might not be the best way to do it. It might be better to actually do a string dot split on space centimeters. So let's reload this. The reason we might want to do this is if we go back to our toy example and we do small data dot, we'll do it in the next cell. We run this again, we get this. So what we don't want to see is that this 100 gets the kilograms stripped off and becomes 100 centimeters. That's what we want to avoid. So we might do something like small data height centimeters equals small data height centimeters dot string dot the first thing we did was the extract. We just extract the digits. I'm using parentheses to basically make this a group to know what to extract. But if I do this and we look at small data, we see this becomes 100, which is not good because it was 100 kilograms and it shouldn't be 100 centimeters. It should be NaN. So if we do this again with split on centimeters and run this, we get something that's a bit better. It becomes 100 kilograms here, which is fine. And then if we surround this with a pd.to numeric, I think that this should clean up things as we want. We might have to do something with the errors. Run this. It doesn't, it got rid of everything. Let's try running it again from the start. Invalid objects. I think we need to do errors equals course to get rid of the text ones. Let's see what happens there. Oh no, it's not working. Anyone have any suggestions? What's going wrong right here? Oh, I did split. I don't want to split. I want to strip. Sorry about that. This is meant to be strip. I think this should now work. Cool, look at that. Now it's a nice numeric column, and we see we get NaN here for the one that was just 100 kilograms. Yeah. Oh, the regex sign here doesn't actually matter. I think honestly that's just how it formats it when you're looking at it. So that's not a big deal. Cool. So we stripped that. That looks good. Now we need to handle the kilograms case. So basically the way that I would approach this is let's look at this little toy data again. What I think is helpful is maybe just basically anytime we only have one value. So if there's ever a time where it's the height is not null and the weight is null, or the height is, or I guess we probably could just do, if there's ever a time where this value is not null and this value is null, just basically populate the weight kilogram with the same value. So I think that we could do something like, I'm going to be kind of thinking on the fly here. We could do something like small data, height, small data. Let's match a pattern. This might be a prime. You could. I don't know if I like split on the space. This might be a prime example for like using ChatGPT. So I might use this because this might be how I would actually do it in practice if I just wanted to do something quick. I might go to ChatGPT. I have it here, and I might do something like write a new one. I'm trying to split a height and weight column called measurements. Oh no. Sorry. Start over. I might do something like, I'm trying to split a height and weight column called measurements, but there are some edge cases I can't handle. Please help with the examples that are just 183 centimeter or 150 kg are of the format. And then I might paste in the code we had in our small data. So this is just that code. And I might just see what it says to do. I don't like this. Sometimes it's good. Sometimes it's bad. I feel like I didn't word mine maybe the best. I don't like this solution. I feel like it's getting overly complicated. Have to say please in case the AI lords are watching. Yeah. Please, ChatGPT, can you try that again? Can you try that again? And this time, just if it splits and keeps the value, and if it splits and only has one value, also copy that value into the weight column. This might be a simpler approach. And yeah, no, you could do this like I can figure this out within Pandas code, but it's also sometimes just easier to ask ChatGPT to see if it has something that you can do. And look at this. I like this fill NA. I don't need this extract value though. All I like is this. So I'm going to go back to my code. I'm going to paste in this line. And this is kind of how I operate with ChatGPT. I take the things that I need and I kind of get rid of the things I don't need. Okay, perfect. That looks quite good. So you see now that any null values, it copied them into both, which is ultimately fine because then we can do something like this. And we can do something like this. And if we then finally look at our new data set, look at that. I'm pretty happy with this. There's definitely ways to do this that are better. But you see we have 183 centimeters here. It's 183 here. NaN for the kilograms. That looks good. We have this one where it fills them both in properly. We have this one, fills them both in properly. There might be more edge cases. There might be like an edge case where this kilograms is, right next to things. So then adding this space here wouldn't make sense, but maybe we could just handle both cases without even including the kilograms and hope that the PD.2numeric is smart enough to know how to handle those other situations. So I might try this real quick. Seems like it didn't quite work because I think it had some errors with how it populated. So I think that if there is a kilogram, it has the space. I'm going to hope. But there are more edge cases, and it really comes down to what I said earlier, that you got to be the judge of how precise you need to be. I think we handled the major edge cases well, and I'm not going to worry too much about some of these extra edge cases. Did I screw something up now? I think we're good. All right. So now we can do all of that. We had all this toy data basically, but basically I can just copy this to our actual data frame that we've been working off of. df. And then we want to do the same for this one. df. So this is now applying it to all of our data. All right, and okay, run. I will delete this, I suppose. I just want to keep things clean, so I don't need to have all this kind of test stuff now that I figured things out. Okay, so get this, run this. And now finally, df.head. We look all the way over. We got our height column and our weight column in their proper units. So I'm pretty happy with that. One thing that's cool is we could look at the tallest player now. So I could do something like df height centimeters, sort values. By default, it's going to be ascending. So we need a, actually, I'm going to do a slightly different. I'm going to do df.sort values. And I'm going to pass in the column name height centimeters, and we'll say ascending equals false. I'm curious, before I run this code, does anyone know who the tallest Olympic athlete ever was? Or have any guesses? And while you do that, I probably should get my charger. One sec. Keith, can you recommend any good data sets for EDA, mainly data visualization? I mean, I recommend just going to like Kaggle or something. Any guesses on the height? I don't think I see any, so I'll just run this line. Trent Bolt. I don't actually know who that is, but is Trent Bolt different than Usain Bolt? We'll see if he's on there. All right, we sorted it. People know good old Yao Ming, basketball player, quite tall, 226 centimeters. Yeah, big person. He's the tallest. Sabonis, is he related to the Sabonis? I think that's on the Sacramento Kings currently. I think that's, yeah. You could also look at the smallest. Smallest will probably be like a gymnast of some sort, I would think. Cool. All right, that's good. Just proof that it works, because I know that Yao Ming is massive. That's I can show people Yao Ming. Yao Ming. Is there a picture? Yeah, like, is there a picture of Yao Ming with someone else? He doesn't look that big, or compared to Kobe, or not Kobe, Shaq. It's a wild picture. He's quite tall. All right, go back. All right, cool. That looks good on splitting height and weight. We want to also probably parse out dates from born and died columns. So if we look at that, You could do something similar here for born and died as we did with like the split and whatnot. But I think what works better is using regular expressions here. And I'm going to kind of go through this a bit more quickly, but let's mark what we've done. We've split height and weight. Yeah. So now we're going to do this one. Let's go down. All right. We want to split height, or sorry, not parse out dates from, oh, it's his father. Cool. On the question I was saying. I can't pronounce his name, but it's Domas' father. My basketball knowledge is not great. I'm an ice hockey player, but I knew Sabonis is very good. Parse out dates from born and died columns. So if we look at our data frame, we want to get the dates out. What we can do here is what I think is the easiest is we can use regular expressions. So I might do something like df born date. I think that probably should be good. Equals df born dot string dot extract. Then we're going to pass in the regular expression. We want 2 digits or up to 2 digits. It might be like just 1 digit if it's, yeah, like 1st of April. So digit plus is 1 or more, followed by a space, followed by some word characters like April, followed by 4 digits, digit 4. That should match this type of format. So if we run this, and then we look at our data frame, and we have so many columns, I really want to get rid of some of these extra columns. I suppose I could do that at any time. Maybe it would make sense to, just so people don't have to look at all of this as I go. Oh no, why did it not work? I feel like this should have been right. String.extract. Oh, I put the R in it. The R should be outside of it. Cool. Look at that. So that extracts just the date using a regular expression pattern. So some digits followed by some words followed by exactly 4 digits. That matches up with digits plus words, word characters, and then exactly 4 digits. You end exactly after that 4 digits. And then it extracts that pattern. And you got to surround it in parentheses, I believe. I don't think it would work if and maybe it would work if we didn't have the parentheses, but there are some niceties that you'll see in a bit by using this parenthesis format. That being said, it looks pretty good from this, but again, one thing that I recommend is I'm going to just call this like date pattern is equal to this. Strip time, it might work. Strip time, strip date time, strip. This is the comment I'm looking at right now. If anyone has a liner with leveraging this, let me know. I definitely have used this function in the past, but I feel like it's one of those ones that I forget. You know, I end up on a Stack Overflow post and I end up using this function, but it maybe doesn't come to me immediately. But I'm curious. Let me just try this on the fly. We'll see if we can use this properly. Df born dot strip. I don't even know how to process this. I think you might need a datetime object first to get this. So it might not work unless it's already a datetime object. Not positive. Feel free to let me know in the comments if people know otherwise. So I'm going to go back to what we had. That string.extract date pattern. Okay. One thing we might want to check though is, do all dates, if there are a date, do they always follow this pattern? So one thing that I might recommend, how did I master the regex? Is one of these comments here. I really like a site. There's a couple sites that I like. And I think in the video I have on regular expressions, I list these. But I really like regexgolf.au, I think it is. Oh no, regexgolf. Alf.nu. I love this regex. Oh, no, did it get taken down? I hope it's no longer. It's still there. I don't know. I can't reach it right now. That's a bummer if it is. There was this regex golf that I really liked. And then there are some videos that I've liked, but I have a tutorial on regex if it's helpful. I am not in Edinburgh if that question is for me. But one thing we want to do here is check to make sure if everything matches this date pattern. So what I might do to check that is I might do df.born.string.match date pattern. And then I might do, again, same thing as last time. The null values here will say are false. And I might do the ones that don't match. So what examples don't match that format? Okay, so we see we have some that are like just 1876. Is there any other formats? And then I might also do and df born dot not na. So I'm basically just trying to see the different types of formats they exist. Okay, so we have like sometimes it's just the year, no location, just the year, no location, year plus location. Yeah, this is what we're doing. You're showing me another pattern. Yeah, I like your pattern too, Llamaland. I see regarding the datetime, probably need to use the datetime module. People know in the comments after this, we finish this video, feel free to let me know about the best way to use that function. I need to review it. But we got, okay, so we have a few different formats. And this again is where you have to ask yourself what's important, what's not important. Do you need to know the day information? If you do, then maybe these examples that are just year, maybe we drop them. Maybe they become NANs when we extract out the date. If we only care about the year and we don't care about the day and the month, then maybe we make a year column and it's born year and it just grabs the 4 digits here. So we need to ask yourself these questions, but it's good to just be cognizant of what are the different examples that we're dealing with, and then kind of handle them appropriately. One easy thing we could do to also grab out like years like this is we could add to our pattern something like OR. So this straight line is an OR operator, digit 4. This would just match anytime it sees 4 digits in a row, and we can kind of assume that it's probably going to be a year if that's the case. And then it would extract out both the day, month, year, and just the year. So that's one way we can do it. Yeah, you have to kind of be the judge here. I'm kind of unsure of what I think is most important. Ideally, I would say we capture as much information as possible when we don't lose information. So maybe doing a pattern like this is nice. Rerun this. Run this. I'm trying to see if there's an example that has just a year. Again, like you could do that kind of the example we did before with like a small subset of data. We could do, small data again equals 1896 or 1895, 12 December, 1900. So again, I just like sometimes doing this because I find it's helpful in figuring out what works, what doesn't, than trying to do it on a whole data frame where I don't know all the pieces. So I'm just curious what this will do. Okay. Oh, what happened? Oh, this should be a list. Okay, see, so that parses out both those dates. And if we added some like in Scotland, I don't know, in Boston, we'll see that we still just parse out what we want. See, just gets those dates. So this pattern, grabbing these extra 4 digits, made it a little bit easier when we were doing our extract step. I'm going to get rid of all of this small data stuff and just go back to our data frame though. Final step here is basically just using the datetime object. And if we pass that in, run this, it's not happy right now. What you might need to do is pass in errors equals course to basically just fail gracefully. What is it failing on? It probably needs a pattern. I'm just gonna say mixed. Oh, format. Int has no object lower. What is it calling this? What is it mad about right now? I don't know what it's mad about. Anyone have an idea on why it's mad at me right now? pd.toDatetime. Am I trying to do too much? Would it be easier if maybe I just did this on a separate line? I might just keep it as this. Yeah, this might be a Stack Overflow type thing. I'm going to try it one more time. I'm going to just, instead, this time I'm going to do df born date that already has been set equals pd.toDatetime of that same column that we already parsed out. Did that work? Why did that work? Why did it not let me do it in one line? I don't know. It let me do it once I created this column and then run it on this. So now if we look at our born date, and then we look at, I guess, .info, I think, can we call that? If we do df.info, we'll see that now this is a datetime object. And we can do df born date equals, or dot, you can do something like, dot date, dot year to get like cool things like just getting the years out of those. You could just get like the month if you ever wanted to analyze most popular months people were born. So if I wanted to do like df born date dot year, I wanted to see all the people in, let's say, I don't know, 2000, like who was born in 2000. These are very young Olympic athletes. We do that, and we see now we have some names of people. Probably not that many, because the last Olympics this has is 2022. So these people would be pretty young. You could also sort, on our born date. And we see that's like people born in 1828. But if we did ascending equals false, we get the youngest athletes at the most recent Olympics. It's like a couple of names that pop up for me is like Sky Brown. I know she's a female skateboarder. I think same thing with Raisa Leo. Cool. All right, so that gets us our born date, and we can basically just do exactly the same thing with a died date. You can use the same exact pattern, just change the names of this. And run this. Now if we go to df.head or df.info, we see now we have datetime dead. And one thing that's nice, I don't know if this is nice whenever we're talking about death, but the non-null values, we have a lot more non-null values for born than died. So there's just a lot more athletes that are still living. And so this kind of makes sense if we just think about it. One thing I will say, I will call out, just because I know this is tricky. With our previous example of like 1896, I think that when we do this step, even though, it's kind of a valid date here, I don't think that it will properly convert this to like a year, date, and time during this step. I think we'll drop a year like 1896. What I might recommend, if year is very important to you and you need to be very precise, is just parsing out here. Like, I think if we just did %y and just grabbed the year, percent, and ran this again, I think what we'll see over here in the dates. Oh, I guess it doesn't like this at all. Moral of the story is I don't want to get into too much details, but if having the year is quite important to you, I wonder if they're. I might just save it as a different column. So I might do this step, or like just do a pattern like this. Just pull out the 4 digits consecutive, and then just save this as like year or something like that. Go back to what we had. So I guess like what I'm saying is born year would be equal to something like PD, it'd be like df born dot string dot extract just 4 digits. And then what we would do is do something like df born year equals df born year, and then we could convert this to like a numeric type. We don't really need it to be a date time because we don't have the full date. We just kind of care about the year. So 2 numeric here is probably fine. Run this real quick. Do we have born year? Oh, this had an issue. I didn't like it because it didn't have any parentheses. See, this would just get us our years and we wouldn't drop anything. So if that's useful, maybe it's useful. But I think we accomplished our goal here of getting out the dates, born and died. Parse out city, region, and country from the born column. This is very similar to our last task, but now we want to get this stuff instead of the date. So we can follow a pretty similar process. So the process here is going to be, get city, region, and country from born column. We can follow basically the same type of approach, have a pattern. So paste in this pattern. This time, though, it's a different pattern because we want things like Madrid, España. Let me just look at the head of our data frame again. And I'm going to specifically, just so we can read it a bit easier, we'll just look at the born column. Okay, so like we want to grab this information. So we want the stuff after the in. So it's like, how do we figure out a pattern here? I might honestly do something like in space blank. We need some word characters. That's our first group. So the first set of word characters is what we're capturing here. And this is all regular expressions. So I'm going to call this location pattern. Then we're going to follow this by a comma. And regular expressions are extremely helpful. ChatGPT, et cetera, can help you out a ton, I feel like, with the regular expressions. So check ChatGPT out. Okay, there's a comma. And then we want to get our next thing. So there's some sort of space characters. So like I'll say, one or more spaces, probably. Then our next capture group is going to be some more word characters. And then finally, we want one or more spaces, followed by, we want to capture the stuff in the parentheses. And I'm doing a lot right here. So hopefully this will make sense and I'll show how this is going to operate. But basically, I want the stuff in the parentheses. So I want to escape the parentheses character because I don't want to start capturing yet. And then I want to have the stuff in the parentheses. So now we're capturing some word characters. Word characters are just like letters, I think, in numbers. And then finally, we want to escape this last parenthesis. A lot here. Honestly, you could paste this into like ChatGPT and say, explain this regex. It will do a better job than I probably could on this. But basically, what this lets us do then is we can do something like df city. This is going to be, I guess, called born city, born country, or born region. Because we see like it's not really a country. It's like, or I feel like sometimes it's a region, sometimes it's a country. This region is states when I looked at United States type stuff. So I'm going to just call it a region. I think that's good enough. And then finally, the country, the born country is the third thing. And we'll set that equal to, basically we have three capture groups. This is going to be our city. This is going to be our region. And this is going to be our country. So if I do df born.string.extract, pass in this location pattern, it's going to work like magic if things go as I hope they do. Of course, they don't. All right, this worked. Okay, it ran. Now let's look at df.head. Okay, we're getting nothing. It didn't capture anything. Why didn't none of this work? Oh, we got to do the expand equals true. Whenever we're extracting and things we're trying to set to multiple columns at once, we're going to have to do expand equals true. Try this again. And still nothing. What did we do wrong? It looks right. Comma. What happened here? Why is it not working on any of these? Oh, I guess one issue is if it could be word characters and space characters. We might need to increase the number of characters we have here. So I'm going to do either a word character or a space character plus. Word character or a space character plus. And plus means one or more. And I think the last one should just be word characters. Still nothing. What are we doing wrong here? Yeah, that's a good idea. Let's see if we're getting anything in the location pattern. I'm trying to do too much at once. So let's just do string.extract location pattern. Looks like nothing is ever happening there. So maybe we just need to simplify this. Let's get rid of this in. Maybe still nothing. It is making it 3 columns, which is nice. Born.string. That's right. Let's try to simplify this. I'm going to comment this out. Let's just try a new regex pattern. Okay. We definitely want to capture some word characters, and then a comma, then a space, and then some more word characters. Let's just try what happens if we do like a simple pattern like this. Okay, that's starting to get stuff. So it seems like we screwed up something elsewhere. Then it follows it by this stuff here. Is there a space between? Yeah, there's another space here. I think I was getting tripped up on maybe how I was formatting some of this stuff. Space, and then escape the parentheses, and then parentheses, more word characters, escape the last one. I do see some people, oh, try with regex 101. Yeah, that probably would have been a good solution. I feel like I'm trying this a bit on the fly, but that might be how I would do it if I was not doing a live stream right now. Perfect. Let's see what happens if we do this. Perfect. This looks pretty dang good. I think the thing is, why is it failing on some of these? And it looks like it's not getting quite the right values on some of these. So let's run this again. Run the head. So like we see here, Bordeaux and Hironde. That looks good. This is a more complex example. And like we see this one, it's like Perth 8th district, I believe this is. But when we capture it, we're only getting this 8th E, VIIIE. Oh, did I have the wrong slash, I guess, in the space. I think that was probably the issue. But what we need to do here is we can't just use word characters because this could have word characters. It could have space characters. You could do something like that. I think same thing with this. It might not just be word characters. It might also be space characters. So let's see what happens if we run this. And it's giving us a little too much now. We want in space there. This looks pretty good. We still are missing some, like the second value is missing. If we look at our second value in our df head, we should get this crazy thing, Pyrenees Atlantique. So we also need to maybe add a dash character to both of these. So I'm kind of figuring out this regex on the fly. Regex 101 might have been a better way to match all of this. I definitely liked that example or that recommendation, what we're capturing. Maybe it'll be worthwhile for me to just go to regex 101 real quick. Thank you for the suggestion. So the regular expression that we're working off of right now is this. And we can insert some test strings. So like in Milan, Italy, I think it's something like this. It doesn't like the cool. So this shows us what it's matching there. That's pretty cool. If I did something like, if I removed, let's look at some more of our examples. Oh man, I'm trying to look at the, oh man, sorry. I'm trying to copy a location from this raw data file, which maybe wasn't the play. Where's the location here? Where's a complicated one? Let me just go back to the data. One thing we can do too that will be helpful is I can actually show off the whole line. If we do, I like to use Copilot for this, show full column width in Pandas display. Copilot will give me some recommendation there. Display max column width, that looks good. Now we can actually see the full columns, which is nice. So if we take this complicated example here and paste it into our regex 101, it's like not matching this at all. I guess I didn't copy the full thing. I think do we need to ignore case or something? It doesn't like these characters, I feel like. Oh, there we go. If we match with Unicode, it worked. But like, look, if we get rid of the dash here, it doesn't know how to match it. So regex 101 is a good way to like check these edge cases. And the groups are very helpful. That's the stuff in the parentheses. Caption groups are super, super useful in regular expressions. So quite helpful. Thank you for the recommendation. Cool. So this gets out that stuff. And now we have a pretty good pattern here I'm happy with. Run that. Run it for all rows. Look at our columns. This gives us, you know, the regions, the countries. And one thing that's cool that we could do now is we could do like df.sort values on, let's say, the born region. We'll do ascending equals false, and we'll look at that. Oh, actually, let's do not sort values. Let's do, sorry, value counts. Cool. We see like England is the most popular region. If we did like the first 10, we see some of the most popular places for Olympic athletes to come from. We could also do like the city here. I do agree. I see someone that says the ChatGPT is still superior to Copilot. I would probably agree there too. Let's see, born city. Budapest, a lot of people are coming from. Toronto, Montreal, Berlin. These are all cities that I expect a lot of Olympic athletes to come from. So it's cool to kind of validate that. You could even look at more. New York City is there. So cool. This looks good. I would say that we now have parsed out city, region, and country pretty well. Finally, what I would recommend we do is get rid of the extra columns. This is really dependent on what you're trying to showcase. But in my situation, if I'm just trying to analyze some of these things, I would say that I guess let's just print out all our columns and we can decide. So our final step is remove any unnecessary columns. And so I might do two things. Like I might save our now updated thing and just have all of the data there. But if I wanted just like a clean, smaller thing, what I would do is df.columns. I would, sorry, I'm just double checking something from up above. And then I would decide what columns I actually want to keep. So I might say columns to keep equals, you created a new column called name off of the used name. So I'm going to just say name first. And you could also order this how you want. Name. Personally, I know we didn't talk about it much, but athlete ID is quite helpful for future tasks. We might want to have definitely the NOC. Probably would want, the born date, born city, born region, born country. Right, we're getting to a lot of columns here. NOC. We probably want the height in centimeters. We want the weight, kg, and we probably want the death date. Okay, that's like some good columns to keep. What I might do to make this a little bit easier to read is make this a new line. I think that this should work. I might have to do a slash character like that. Oh, maybe not. I guess it's smart enough to know. These are our columns to keep. We do df, df small equal, or df clean equals df columns to keep. Now, if we look at df clean, we see we have a lot less information. It looks a lot cleaner than originally. And honestly, I'm pretty happy with that for cleaning this piece of data. This is pretty good in my opinion. This does a pretty good job. Some additional things we might still want to do, and I don't want to make this live stream too long, but we have the name of the country here, where this is just like the abbreviation. So it'd probably be good to get these the same. So either three letters here and three letters here, or have this spelled out. That'll just make it a lot easier if we wanted to look at athletes that were born in a country that's different than the one they're competing for. that would be quite helpful for us. Other things that we would want to do next is basically when I initially showed this data, whereas the BIOS file and also the results file, we only cleaned up the BIOS file, but we'd probably want to do the same thing with the results. And we might want to save this somewhere. So I might say like clean data is a new folder. I might do df clean.tocsv, clean data / bios.csv, and I'll say index equals false. Run that. Now we have that updated file here. And basically, the next thing I would want to do here is I might do, now clean the results file. And if we look at results, we do pd dot read CSV, and we get results / results.csv. Let's just look at this real quick. So this is like each individual row. It might be the same athlete multiple times. So we see this guy is in the first 5 rows. But there's plenty of things that we could clean with this as well. It's like one thing we might want to do is like attach the bio information to this person via this athlete ID. So that's one thing we could do with our cleaning. Other things we could do is like this position, we have this weird like equals sign. So it's like if they tied for 17th or tied for 32nd, like I might split that up. So I might do something like, results place equals results position dot string dot abstract, and just get the digits from it. From this. So like that would give me. So there's more things you could do with this other file, but I might leave that as a task for anyone to do on their own. Like I definitely want to drop this unnamed column so I could, we see that, yeah, this worked kind of how we want to do with the place. But if I wanted to drop the unnamed column, I could just do like results dot drop in place equals true. Results dot head. Didn't find it. Oh, we need to do columns equals. And we now see that we don't have that anymore. So things you can do, I might repeat the process and kind of go from there. I think we'll probably call this. I'll make sure I push all the code to the GitHub repo. Trying to think how to best, I guess you just don't look at the clean data file until you want to see how this is done if you're looking at watching this video back. But I guess if people have gotten to this point in the video, they would have already watched the recording. Any questions, comments, recommendations? There's definitely like more we could do to clean it, but I think that like this is probably a pretty good stopping point. So we did our cleaning. Finally, yeah, questions, further recommendations. What did I miss? It's hard to do this in a live stream. It's definitely, I feel like I'm thinking about multiple things, but hopefully this kind of covers a lot of questions people might have. When is the next? When's the next live stream? I'm not sure. I'm going to try to figure out a schedule of some sort. I feel like I'll typically do them Friday, Saturday, Sunday, kind of like weekend type days. What I'm going to try to do, I feel like, is I really want to get to the point where I'm uploading once a week. But it's just not very realistic for me to upload once a week. So I'm thinking that in the weeks that I don't upload, maybe I try to do a live stream instead because they're just a little bit easier to do. There's no editing, etc. So probably Friday or Saturday at some point, but probably not for a week or two. I'll try to do a good job. If people in the comments like know of ways that they see like streamers that they follow as like schedule or something, and there's a good way to do that, I'd love to know in the chat or in a comment just on how people kind of keep a schedule out because I'm very new to this live stream game. Any other questions? I'm happy to answer questions probably until 3 p.m. Eastern, so another 9 minutes or so if people have extra questions. Is Visual Basic better than Anaconda Jupyter Lab? I'm not knowledgeable enough. I feel like they're not. I think you're meaning Visual Studio. Visual Basic's a programming language itself, but Visual Studio better than Anaconda Jupyter Lab. It's really personal preference. I've just been doing a lot of like I feel like bigger software projects where maybe it makes more sense to do Visual Studio Code, and then I just kind of keep in Visual Studio Code for my analysis, my things that I might maybe in the past have just used Anaconda slash Jupyter Lab. So all personal preference. Like honestly, I use Vim a lot of times too, and Vim is like the most basic text editor you can get. So it really there's no one right answer. It's what you like best. Any other questions? I'm happy to chill for a couple more minutes. Do a fun topic like cracking the pick 3 lottery based on regression or simple trends. I feel like I don't know if I understand this enough. If you leave a comment on what you mean by this, maybe I can look into it. But that definitely down to do fun topics in the future for live streams. From my understanding, this would be just like generating all pick 3 lottery numbers, and then like buying tickets or something for all of them. You'd write some sort of program to do that. I'm not sure. Shout out to this polar seltzer. I don't know if anyone's had this mango limeade. Quite good. Quite good. I'm new to this channel. Do you upload data science related videos? I definitely do. I recommend checking out my video catalog and seeing if there's anything useful there for you. And if you ever have topic ideas, let me know. Let me throw a caption up here. Let's I see some more questions on like Jupyter Notebook or Visual Studio Code. Again, like really personal preference. Like sometimes I just like using Jupyter Notebook because I feel like it's clean and nice to look at. But sometimes Visual Studio Code I like because of the extension access. There's a lot of extensions that are super easy. I see a question about certifications. I don't know enough about certifications, unfortunately, for data analysis. I mean, I'm always of the opinion like do as many projects as you can. I would say I think of like certifications as like what really matters is you learn the skills. So wherever you feel you learn the most or hear people learn the most, that's the certifications you should do. Because at the end of the day, if I'm interviewing a candidate, I'm more concerned on their skills and I'm trying to dive into that than what certifications they have. I mean, the way that I think about this is like you can have hundreds of people that go to the same college, but they're not all the same. They're not all the same skill level with, computer science. Same thing with certifications. You can have 100 people do the same one. They're all over the place skill wise. So try to pick things that you feel like you learn the most or just have the best reviews of really learning the most. Did you study a lot of linear algebra at MIT? A bit. I feel like it's useful for, um, I mean, I did a linear algebra course, so I, did, I don't know what I would say most college courses do in linear algebra, and then you just use it a lot in like algorithms type classes. Like you do a little bit of linear algebra type stuff within, um, your computer science work, but nothing crazy. Just your standard linear algebra college course, I would say. And then maybe a little bit of it in like differential equations. Uh, I probably won't. I see someone ask about C++. I probably won't do a ton with C++. I'm not an expert by any means, so I feel like usually I like to do uh, live streams and videos on things that I feel confident in. And C++, I'm a little rusty in right now. It's just seeing some things that seem helpful on the screen. Actually, one thing I'm curious about, what does the overlay look like? This is what I'm seeing. It's kind of cool that I can just do this on the screen. Go. I guess the new ones are at the top. I definitely, yeah, I think Andrew and I never can pronounce his name properly. He has a great machine learning like theory course. I think that's a good like foundational course. So I definitely do recommend that. I'm gonna hide this chat. I like kind of like picking out certain questions. I was just curious what that looked like. I see a question on MS Fabric. I'm not like I would say an expert in a lot of data engineering type things, so I'm not actually super familiar with MS Fabric. Um, so I don't have too much thoughts on that, at least right now. I love seeing these types of things, though. It's like makes me always cognizant of things I should learn and become more of an expert in next. Any other questions? I think we'll call this in a second. I feel like I'm seeing questions slowly trickle away, and I'm also seeing people, viewers at least, kind of start to trickle out. All right. Awesome. Well, I think I'm going to probably call it there. I'll try to do another live stream soon. Thank you everyone for joining in. This was a lot of fun. Hopefully it was educational for everyone. I had fun. I feel like slowly getting more comfortable with the live stream format. So definitely want to do more. If there's ideas for future videos, let me know in the comments. Um, Trying to think what else. Yeah, if you haven't subscribed and you watch this live stream and found it useful, make sure to subscribe. All the generic YouTube things to say. Make sure to like the video, subscribe, follow all the socials, etc. You know the drill. Cool. Now as I say all that ending stuff, I feel like I see a lot of more questions coming in. Feel free to leave those questions in as an actual comment once this live stream ends, and I'll try to like kind of go through and maybe respond to some of them. It might be hard for me to respond to them in the chat after the video is done. How long it took you to get? I do like this one. This is like a final one. Get very familiar with pandas for data analysis. One thing I would say is I'm still learning every day. I just posted a like 5-hour exercises video, and I learned a ton through the process of completing all of those exercises. I would say for me, I first started with getting good at Python, and maybe that took a year or a year or two to get like really comfortable with Python. And then I think pandas I picked up pretty quickly. It was like I used it a ton in one specific job opportunity, and I feel like it was like a 3-month um, consulting role, and I just used pandas every day, and I felt very comfortable with it after that span. But that was also already having the base knowledge of Python there. And I ultimately, after that, like 3 months of heavy pandas usage, I feel like that's when I first made the complete pandas tutorial. That's the most popular video on my channel. So hopefully that's a little helpful. What type of watch? I like this. It is a Garmin Venue 2 Plus. It is a Garmin. I like it a lot. I really like this watch because it has a ton of battery life. I feel like I get like a week out of one charge if it's charged fully, and I, run every day and usually log my runs on the watch. Yeah, definitely, like, everyone's timelines are different, so don't ever feel bad about, like, do your best to be consistent and try to learn, but, like, we all learn in different schedules. Some things that I find easy will be hard for others, and vice versa. Some things that you find very easy, I'll struggle with. So, we're all on our own schedule. Um, if the data I need to clean is stored in a database, would the approach be similar to what you did in this video? Yeah, this depends on how much data you have. Like, luckily, we were working with a pretty small data set here, so I was able to load it all into memory and just do all the cleaning steps on my computer in memory. It's fairly similar if you're in a database. I would say there's more like protocols you'd want to take. You just want to make sure you like aren't ever deleting anything, that you have backups of all your database before like you get, completely get rid of some things and replace things. You also might have to do it in like iterations. So you might like clean up chunks at a time, add a new column, and like do things chunks at a time with SQL or Python, etc. It might not all be in one go because you can't load the whole database in memory. So it might be a more iterative approach, but largely a lot of the concepts are the same. I would just say, yeah, anytime you're working with the database, just be careful that you have things backed up and you're being cognizant of not overwriting things or dropping a database in production. No smartwatches. Dumb watches are perfectly great as well. I do not judge. I feel like they're a lot of regards. I try to limit my technology, so I feel like I like the Garmin watch because there's not like all apps and stuff on this. Um, but I also just like I try to keep my phone off. Like I'm trying to be more old school myself, honestly. All right, now we are past the time that I thought we'd probably end at. So I'm gonna call it. Thanks again for everyone for watching. Subscribe, like all the things. But yeah, thanks everyone for tuning in. This was fun.